Good evening. This is Aayush Sharma. I'll be presenting a paper named Application of Machine Learning for Facial Stroke Detection. So, general information about this paper. This was presented in 2018 IEEE 23rd International Conference on Digital Signal Processing. It's basically a computer vision implementation which uses machine learning algorithms to classify. So, the date of conference was 19 to 21st November 2018, and basically the data set they used was a total of 69 images were used for training and testing with different kinds of features. In this paper they extracted around 89 feature values, which are the asymmetry index as well as the structure similarity index from the region of the eye and the mouth. So let us go over an overview of the particular session, why this paper was needed. So cerebral hemorrhage and CA are the main causes of stroke. Both obstructive and hemorrhagic strokes may cause abnormal brain functions, and cerebral eczema and poor blood circulation may result in the death of brain cells, which can lead to permanent damages in the brain, like behavior, memory, spasticity, and sometimes death. So according to a statistical data from WHO in 2015, an estimated of 15 million people die from cardiovascular diseases, out of which 66.24 million people die of stroke. Stroke often causes the ability, which loss of ability, which is one of the main causes of adult disability. So facial sag is basically one of the biggest symptoms when a person has a stroke. Its medical term is Bell's palsy, and Bell's palsy is caused by facial paralysis that results in the hard to control facial muscles on the affected side. Let us talk about the model. So the proposed facial stroke recognition system consists of 5 main modules: face detection, facial landmark localization, facial feature calculation, feature selection, and classification. And in this face detection, the combination of histogram of gradients, feature, and SVM was adopted to track faces. So special feature about this paper. Feature selection method can obtain a higher degree of discrimination feature set from the original feature set. So they proposed an SFFS based feature selection algorithm, which they call random generated SFFS, or short for RGSFFS, to extract significant facial value features. The system captures eyes and mouth regions of the face automatically, then 89 facial features were extracted from each face. The RGSFFS was applied to select discriminative feature set, and finally based on the selected features they used support vector machines, random forests, and Bayesian classifier to classify facial strokes. This is the flowchart for the proposed system. Now coming to feature selection. RGFFS is an extension of the SFFS, and the RGFFS basically includes 3 major steps, which is generation, inclusion, and exclusion. More of it is in the paper if anyone wants to know more about the particular algorithm that they proposed. This is basically the algorithm that they have implemented for RGFFS: generation, inclusion, and conditional exclusion. So to demonstrate the performance of the proposed RGSFFS algorithm, the SVM, RF, and Bayes classifiers were trained with all features, features selected by SFFS and features selected by RGSFFS. They compared the classification accuracy and feature number of SVM, RF, and Bayes, and with all the features, non-feature selection, SFFS, and RGSFFS. The accuracy for NFS, SFFS, and RGSFFS in SVM were about 81.8, 90.09, and 100% respectively. We'll get to know more about it in the next slide. So basic accuracy of RGSFFS increased by 9.91%, and the feature numbers decreased from 66 to 53, which means that a relatively small number of features can be used to achieve better accuracy with SVM. And the accuracy of using SFFS and RGSFFS in Bayes is the same. And the number of features that were reduced from 17 to 19, indicating that the 9 features of RGSFFS are more discriminating than the features of SFFS. This is the comparison feature table. As we can see, SFFS for NFS gives 81.81, SFFS gives 90.09, RGSFFS gives 100% accuracy, with features decreasing from non-feature selection to RGSFFS. For random forest, the accuracy started for NFS was 72.72%, SFFS being 90.09, and RGSFFS being 95.45. Again, the same trend of decreasing features from non-feature selection to RGSFFS. For the base classification, the accuracy started at 81.81% for non-feature selection, while SFFS gave 100% and RGSFFS also gave 100%, within same trend of decreasing feature sets. So, in conclusion, a novel feature selection method called random generated sequential forward floating search was proposed to go through a significant feature set for the detecting facial stroke. The experimental results show that the proposed RGSFFS exhibited better performance than those of SFFS and other paper methods. The proposed method was compared with the findings of a similar paper as we have stated above. The experimental results show that the proposed method achieves higher accuracy than the other paper's method. My thoughts on the paper. So this paper is interesting and has good application value in real time. The complete accuracy it achieves is astounding and towards a path. But this method the paper implements is not in real time, and it would be more beneficial if this can be done in real time. Basically what they do is the user will click a photo of himself, and then this implementation would work and give results. If this can be done in a more real-time environment, it would be really beneficial, as no one has particular time, especially in old age, to come and like click their own pictures. So they have a good accuracy results, but this could be also be due to the smaller data set. In order to train a model which get verified results and better results, and to get the actual implementation of the proposed system, the expansion of data set is a must. Thank you.